Alrighty, let's start. So I want to start in on a new topic today. This new packet. Anyone need one?
Yeah, sorry.
Okay. So let's talk about quadratic functions. And before we say anything about like what they are, let's just absorb that like you've seen them already because they're important for lots of different modeling. And maybe here is the most elementary model you might see that uses them. So let's suppose you go up to the top of Hibbard, which I am assorting is 45 meters tall. There'll be an extra credit coming later in the semester where I ask you to determine the height of Hibbard Hall. Not yet, but that's coming up. I'm assorting right now, it's 45 meters tall. I haven't measured it or checked that claim in any way. And drop a bowling ball. The height of that bowling ball as a function of time is then given by approximately -5t squared. So some contribution coming from acceleration due to gravity. Plus 45 t in seconds, h in meters. So let's suppose I give you this model and ask you to make a prediction for how long it will take before that ball hits the ground. All right, before we even do that, anyone have any objections to that model? I mean, maybe you'd rather that like -5 be -4.98 or something. But that's like pretty close to 5. The acceleration due to gravity isn't a whole number of meters per second squared, so. Well, that's close enough for me. Anyway, so let's suppose I give you this model and asked you when does this ball hit the ground. How would you find that?
Make t equals 0. Or have the y value equal 0.
Yeah, the y value, the output value is 0. That's what it means to hit the ground. So if you want to figure out when it hits the ground, you just need to solve height equals 0, also known as -5t squared plus 45 equals 0. That look like an easy equation to solve? Yeah, solve it. Need one of these? All right, how do we feel? When does this ball hit the ground?
At 3 seconds.
I hear 3 seconds. Do I hear a second? Awesome. Yeah, I agree. Anyone want to talk through that one? Cool, let's talk through it. I was going to say we're going to talk it through anyway. T equals 3 seconds. So to solve that equation, what strategy did you follow? Or I guess like what move did you make first?
Subtract 45.
That seems reasonable. There's only one t in there, so if you can just get like everything that's not t to the other side, then you'll know what t is. Subtract 45. Cool. What next?
Divided by -5.
Seems sensible enough. 45 divided by 5 is 9.
Integrate on both sides.
And right, whenever you undo a square with a square root, you introduce a plus or minus sign.
It's impossible to have negative time.
Yeah, negative time doesn't make sense in this model. It does, like, makes negative time mean something. It's like 3 seconds before you drop the ball. But 3 seconds before you drop the ball, you were probably carrying it to the edge of the roof. This model, if you use negative time, doesn't have you dropping the ball. It has you like standing at the roof, the ball flying up to you, and then you drop it, which isn't what happened. Negative time is not in the domain of the model. So you just have t equals 3 seconds. So the ball hits the ground 3 seconds after you drop it. That feel pretty good? All right. So now I'll wax a little bit abstract. What's a quadratic function? A quadratic function is something like the function that we just studied. A quadratic function is any function of the form a x squared plus b x plus c. I mean, it's technically fine to use uppercase letters there, but I'm going to use lowercase letters for reasons that might become clear later. With a, b, and c constant. So things like linear functions, but there's also a square term. That's all. A quadratic equation is any equation that can be put into the form 0 equals ax squared plus bx plus c. So I think the first thing to remember is like, what is the general thing that solves quadratic equations? And maybe to point out we need a general thing. The strategy we just used above, like, it won't work if I ask you to solve an equation like the one that's underlined in yellow right now. Yeah.
But the quadratic formula was negative b plus or minus square root. Or, yeah, something like that.
Yes, what you said is true. There's a formula called the quadratic formula. Notice, this is a quadratic function.
Oh,
This is a quadratic equation.
yeah.
So on the next page, there's a general tool that like will black box for now and just be like, it's a formula that works and we're not going to explore why. That solves any quadratic equation. And you need it because like, if you have a situation where there's like 2 instances of the unknown variable x, like you're going to need to do something because you're not going to get x on its own without combining the x's together somehow. And so you'll need to be sneaky to do that. Or let's establish the quadratic formula. So here's a fact, which is an excellent segue. I was about to talk about it. There's a formula that gives solutions to any quadratic equation. So if you ever encounter a situation where you want to know ax squared plus bx plus c equals 0, what is x? This is just going to hand you the solutions. How many people just remember the quadratic formula? Let's hear it.
So that would be negative b plus or minus the square root of b squared minus 4ac. That's all over 2a.
You agree? Awesome, yeah, there's the quadratic formula. So the quadratic formula says that whenever you have a quadratic equation set equal to 0, here's a formula, which maybe it just looks like a magic formula. That just tells you what the solutions to that equation are. And let's use that to do something. Let's suppose I asked you to solve x squared plus 2x plus 4 equals 1. So there's a small trick here first. Is that in the form that the quadratic formula applies to yet? Now, what do I need to do first?
Subtract 1.
Yeah, I need a 0 on the other side, so let's get a 0 on the other side, subtract 1. So, by subtracting 1, we'll get x squared plus 2x plus 3 equals 0. Nice, so it looks like there's my a, there's my b, there's my c. Let's write down the quadratic formula and see what it gives us. So, by the quadratic formula, x is equal to negative b plus or minus the square root of b squared 2 times, well, let's just write down 2 squared minus 4 times a. What should I use for a in this case? 1, right? The thing next to the x squared is 1. 4 times a times c all over 2 times a. And I think I want the goal of a maximally simplified exact answer and decimal approximations. So let's start simplifying that. Yeah.
Code.
Agree. I'm glad you're inside.
There's a fundamental problem in that 4 minus 12.
Oh, yeah, there is a problem in there. Yeah, so let's simplify this out and see what happens. So, simplifying this, I see negative 2 plus or minus, what's the total inside that square root? Negative 8, all over 2. 2 times 1 is 2. Yeah, I agree. There's a negative under that square root. That's a problem. So what conclusion do you think you should make?
That this particular equation doesn't have any solutions.
Yeah. This equation, I'm going to add a word to that sentence, has no real solutions. And you know what? Whenever you see a situation where the conclusion is there's no answer to this question, that's an interesting result. Let's double check that. How could you do something totally independent to this to check that this has no solutions? If you're allowed to use absolutely any tool you would want.
I would use maybe factoring,
Say later?
like factoring so that you get the x plus something and the times x plus something.
We will do some factoring. I'm not sure if you could use that to directly show that this thing has no solutions.
Yeah, the other one would be x equals 0, in which case you get 4 equals 1. Or 3 equals 0.
Oh, sure. I think that the result is this thing won't factor though. Let's hear something else. Yeah.
Can you just plug any real number in?
Well, but there are too many real numbers to plug in like all of them at once.
Can you
But
just use decimal?
yeah, let's look at a graph.
When you wanna solve like for imaginary answers?
I will, but not yet.
Okay.
In a few days, we'll say like, what's an imaginary number? Why should you think about them? But for now, I'll just settle with let's graph. Let's look at a graph. And if you want to use your graphing calculator to graph, use it. I'll pull up Desmos because the graph looks nicer and it's quicker anyway. So, I want to know when is this thing equal to 1. So I'll graph y equals x squared plus 2x plus 4. There it is. I'll also graph y equals 1. Those two curves cross? Nope. So there's no real solution. There are going to be two imaginary solutions, and the quadratic formula does tell you them. But looking at a graph never will because, like, I don't have enough dimensions to do a complex graph here. Neato. People feel pretty good? I think I'm going to have you do one again. Solve for me that equation. x squared plus 6x equals 16. And this one does have solutions. Can conform. Alright, once you come down on an answer, maybe compare it with folks around you. Maybe check by looking at a graph if you got the time. Alright, let's hear it. Yeah, I hear a -8 and 2. I didn't do it, so I can't answer yes or no. Can someone else answer yes or no? Alright, I hear some agreements. X equals -8 and 2. Neato. And again, like, I've got a graphing tool, so you phrased it as a question which makes me think you're unconfident, so let's become confident. I hear some disagreement.
Well, just because the +6, that would be because that would be -8 minus 2. Now you get a +6, and then -2 times 8 would be -16. So
Cool.
I feel like you would flip that 8 is positive and 2 is negative.
You know what, let's check. Let's pull up a graph, we'll see what it says, and then maybe we'll go through the steps and see if we can synchronize where something went wrong. X squared plus 6x. There's the thing that I would like to graph. And y equals 16. Y value's off the chart. Graph is saying -8 and 2. So let's go through and see what went on. So, how many people use the quadratic formula like the problem said? Cool. Any folks use a different strategy? Cool. The different strategy is also on the next line, so you're already ahead. Got the same answer then?
Oh, yeah.
Okay, something about an 8 and something about a 2. Let's go through this walk. So you subtract the 16 to the other side, x squared plus 6x minus 16 equals 0. So quadratic formula says x equals -b plus or minus the square root of b squared, 36 minus 4 times a times -16 all over 2. I at least write down the things correctly? All right, well, you all know what 4 times 16 is already, because you already did the problem. 32? 64. And it's going to become positive, so let's cancel those negative signs. Is the thing inside the square root 100?
Yeah.
Awesome, okay. Negative 6 plus or minus the square root of 100 over 2. So I see negative 6 plus 10 over 2, and negative 6 minus 10 over 2. So far, so good. And so certainly, well, let's just write down what each of them are. Negative 6 plus 10 is 4. Good, I was about to say negative 4, which would have been wrong. Divided by 2 is 2. So that gives me the 2, that checks out. The other one is negative 16 over 2 is negative 8. Yeah, so I think I agree with the ones written down. Did you catch where something went different than what you did?
Well, no, I got the same solution. It's just the way I factored it in my head that can't be right.
Oh, nice, let's factor. Cool, let's talk about factoring. So here's a fun trick. So let's suppose you use the quadratic formula and you get your answers and they both turn out to be whole numbers. It's too late to use this information, but if you do that and get in that situation, then you'll know for a fact there was an easier way to do it. You could have factored. So let's talk about factoring. So here's a game. Subtract that 16 to the other side. If I could write that as a product of two easy-looking linear things, then I could just set each one equal to 0 one at a time. So let's do that. So here's the way to think about factoring. I want to find two numbers that can put in these two blanks so that when I FOIL out this side, I get that quantity. So I need two numbers, star and triangle. I need star times triangle to be negative 16. Because when you FOIL this out, the constant term will be the product. And I need star plus triangle to be 6. So I need two numbers that multiply together to be negative 16, add together to be 6.
Positive 8 and negative 2.
Yeah, so one game is, well, it's most useful to try to factor when everything's a whole number. And there are only so many things that multiply together to be 16. One of them has to be negative, the other one has to be positive. Check them all, but you just told me which one to use. Let's try it. So let's try, so you're using star equals
Positive 8.
positive 8. Triangle equals
Negative 2.
negative 2. And let's just check these in our head. Do those two things multiply together to be negative 16? Do they add together to be 6? Awesome. So that means this is the same thing as x plus 8 times x minus 2. So instead I can solve x plus 8 times x minus 2 equals 0. Does that look like an easier equation to try to solve? Yeah, because right, like I see two things multiplied together and set equal to 0. If two things multiplied together to be 0, what must happen?
Yeah, they have to be 0, so yeah.
Yeah, one of the two of them has to be 0. So, and I think we're about to see what the resolution to your issue was. X plus 8 equals 0.
Yeah, my brain just, because
It is ridiculously
Yes, you're right.
easy to make that mistake. And in fact, so earlier in the semester, the person who's running the tutoring lab is retired, and there was like some interview process. One of the interview candidates held like a little mock seminar that like one would give to tutors, in which she said, "Oh, so now like we'll play with the person next to you, like to talk about a student presenting this situation and find the error." It was exactly this error, and I didn't actually find it in the 5 minutes that I was supposed to be like mock tutoring someone. I was like, "No, this all looks correct. What's the error?" It's super easy to make. Cool. All right, nice. So sometimes you can factor. Do you think you can always factor degree 2 polynomials? Depending on what you mean by can you. If you're going to allow these numbers to be like non-rational numbers, then sure, yeah. But it's going to be exactly as difficult as just the quadratic formula to do that anyway. But when you can get these to be like integers, you can make your life easier. You just can't always do that. Cool. People feel pretty good? Groovy. So, if you like, this concludes the part of today's lecture, which should have felt like pretty light and pretty good. The next thing we're going to do, we'll wind up waxing a little bit technical. We're going to talk about completing the square. And I don't know, if I say completing the square, how many people already have some ideas in their head of what it means? And even how to do it? Oh, nice. Okay, cool. So instead of how to do it, I'm going to start by trying to motivate why to do it before I even say what it is. So here's an exercise. Suppose I asked you to graph this function, y equals x minus 2 squared minus 3. What would you do? What should the graph of that, how would you graph that? Think about the stuff you did yesterday. I know it was a while ago.
Would you FOIL x minus 2? And then make it equal to 0?
No, I don't want to find the roots, I just want to find the graph.
Oh.
Yeah,
I would just do a parabola, move it to the right 2 and then down 3.
awesome. Parabola, because I see a squarey thing. Then go right 2 and then go down 3. So maybe you were like answering this question, the by expanding. I want the graph first. Right 2, down 3. Down 3? Oh, Chris, you poorly planned. Right 2, down 3. So there's the tawny or roundy point, and then it goes up like a squaring function. So the graph will look something like that. We could find x-intercepts and y-intercepts if we want, but I think I'm happy with that for now. Now let's do the other thing. Let's expand this out. If you want to FOIL this out, well, maybe I'll see how people think about foiling. How many people want like me to do some foiling as a demo so that you remember how to do it? Cool. Seeing no hands, expand that out. Tell me what you get. And once you get it, again, like, maybe compare it with folks around you. Nice. I certainly didn't do the walk, but I have designed this particular thing to lead into the next thing. So I know what the answer should be, I think, as long as I did it right. So what is this function? If you expand it out.
It says it right there. Oh, it's x squared minus 4x plus 1. But yeah.
People agree? All right, so let's suppose, given what we just did, I will now ask you, sketch by hand the graph of x squared minus 4x plus 1. What would you do?
That graph.
Yeah, you point to that graph. It's the same function, so it has the same graph. So, here's the motivation. Here's a bit of motivation. If you have something that already looks like a stretched and shifted parabola, it's easy to graph. Just do the stretching and shifting. If you have something that looks like a stretched and shifted parabola, you can FOIL it out to get something that looks like a standard form for a quadratic function. But can you go the other way? If you start with something that looks like a standard quadratic function, can you turn it into something that looks like a stretched and shifted parabola? That's what completing the square is. Completing the square is the act of taking a standard looking quadratic function and turning it into a times x plus capital B squared plus capital C. I've used capital letters here just to make sure that you don't think they're the same as the lowercase letters. Because they are different. This one had a -2 there and it became a -4. So why complete squares? Well, we've just seen it makes things easy to graph. If you have a degree 2 polynomial and you want to graph it by hand, one strategy, complete the square. Now just graph that stretch shifted degree 2 polynomial. You can easily read things off from the graph. Like, let's suppose I want to point at this function. What's the minimum value that function seems to take? -3, and I guess it happens when x is 2. So there's the minimum. So, what's the minimum value of this degree 2 polynomial? -3. But if I just gave you that, that's a harder question to answer. Unless you can complete the square, then you get it automatically. The quadratic formula right now is kind of a black box. Like I wrote down that magic string of symbols and told you that that solves degree 2 polynomials. If you want to know where the quadratic formula comes from, it comes from completing the square. And in fact, there's an extra credit in which you will prove that the quadratic formula is right using completing the square. And completing the square is like, well, let's do it. So completing the square is a task. It's rewriting this in that form, and there's a handful of different mindsets you could have to do it. And in here I've listed like 2. So here's one strategy. So, let's try to complete the square on a specific example. Let's try to complete the square on y equals x squared plus 6x, negative x squared plus 6x minus 3. Let's try to do completing the square to that. And there are 2 different strategies you might use. Here's one of them. So I just need to find a choice of capital A, capital B, and capital C that makes that happen, right? That's all I want. Well, how about this? Capital A, capital B, and capital C are now unknowns. I need to figure out what unknowns make this equation true. So let's just try to like simplify both sides, maybe set some common terms equal, see what happens. And let's start by expanding out expand out the left-hand side. Let's see what that's equal to. So if I asked you to expand this side out, but A, B, and C are like variables, and X is another parameter. That looks like something that we can FOIL out, maybe in a few steps. Cool, let's do it. So, A times, and I'm going to do this in blue because this is the place where I'm going to make most of the changes. X plus B plus C. And let's just walk out what that is. So, the bit in blue, what happens when you FOIL out that? What do you get? Well, I guess we have to do it. X squared first term x squared outside xb plus inside terms b times x, that's the same as x times b, plus b squared. Then you still gotta remember the plus c. That happened correctly? All right, let's just carry on. That is, distribute the a, xb plus xb is 2xb. So that's ax squared plus 2abx plus ab squared plus c. Is that distribution correct? All right, so what do we need to solve? We need to solve ax squared plus 2abx plus ab squared plus c equals negative x squared plus 6x minus 3. That seems sensible enough? Yeah, and like there's nothing magic that's happened yet. the whole thing that I did is I said, well, I know what completing the square means. Let's just write down that equation. We'll try to solve for A, B, and C. Well, shoot, it looks like it'd be useful to expand the complicated looking side. Let's expand the complicated looking side. But now that we can take advantage of something. The only way these are the same polynomials is if the squared terms, well, the squared terms are the same, and the linear terms are the same, and the constant terms are the same. So I can use this to extract 3 separate equations. A better be equal to -1, because the square terms need to be the same. 2ab had better be equal to 6, because the x terms need to be the same. And ab squared plus c had better be equal to -3. That look like a set of equations you could solve for a, b, and c? Right, I just need to know what a, b, and c are. Do I already know what one of them is? Also, which one do I already know? A. I already know a is -1?
Yeah.
Cool. So that means I can replace all the other a's with -1. A is -1. So let's plug in a equals -1. So let's see if I can do that correctly. The yellow equation, it now becomes -2b equals 6. And the pink equation becomes -b squared plus c equals -3. And I still need to know what b and c are. Look like you can solve for one of those 2 variables easily right now?
Yeah.
Which one?
B.
B. What's b?
-3.
I hear a -3. People agree? Cool. So that means I can plug b equals -3. Let's see, there's a square, so -3 squared is +9, but then there's a negative sign in front of it. So -9 plus c equals -3. All right, so can you solve that for c? What do you get?
6.
Cool. All right, so what have we accomplished here? We have now accomplished the following conclusion. -x squared plus 6x minus 3 is -1, so just negative x minus 3 plus 6 is the same as the thing we started with. And let's use that to graph.
Did you pull it?
Oh, yeah. I guess you didn't miss much. All I did is put those blanks in the spaces that are labeled with the names of what goes there. And I don't know, there was nothing magical about those steps. There were a lot of them. But the whole philosophy is just expand out a times x plus b squared plus c. Set coefficients equal to each other and solve. That's like a lot of moving parts, but it's certainly all very mechanical. So there's one strategy. And now that we've done it, if I asked you to graph this function, could you? Yeah, let's go through the motions. So if you wanted to graph this, you could instead graph that. So you start with a parabola, and then you would
Flipped over the x-axis.
because of this, you would flip it upside down, and then
Move it right 3,
right 3,
and then shift it up 6.
up 6. So downward opening parabola, shifted right 3 and up 6. Right 3, 1, 2, 3, 1, 2, 3, 4, 5, 6. Downward opening, and you know what? Just because I want to have the right y-intercept and y-intercepts are easy, let's make sure we have the right y-intercept. Where is the y-intercept of this thing?
That'd be it's -6, or, oh. Sorry,
You're good. I think you're doing it in the way that's
doing it in the wrong order again.
No, I think you're doing it the way the term are also.
Yeah, it's
Does that look easier to plug x equals 0 in? Yeah, you don't have to use the completing the square.
because it's 3. My brain's off today.
No, you're doing fine. Arithmetic is, there are lots of moving parts when you try to do too much in your head. All right, so we can graph the thing. We can graph it by hand. We in fact now know its maximum value. Its maximum value is 6, I guess. That's something. So a few moving parts, but what do you think? Could you do that process? Yeah, so there's one option. Set up an equation, solve it. Those of you who already had an idea for how to complete the square, is this the idea you had as to how you would have intuitively wanted to do it? That's just fine. Tell me about what you would want to do.
Sort of explain, because I haven't did any of that for a while, so it's.
Oh, you're good. I put you on the spot.
Because it just, it comes instinctively now, I guess, so
Michelle.
for me, it's because you have it where it's x minus 3, so I'm like, oh, we gotta have it, so it's, that part is at least a perfect square, but then you're like, oh, you gotta count for the other thing, so you gotta add the 6 to counter.
That's exactly the idea we'll use on the next page. So that's the good other strategy. Is that roughly what you were going to say?
No, I was gonna say something different.
Sure.
It was like to add the 4 and then get x squared plus 6x, and it's like its own squared thing. I don't know how to explain it, but I know how to do it.
Yeah. So the law completing the square is suggestive. Take the bit that has all the x's and try to turn it into a perfect square. And that's the way we'll try to do it. So here's something that might feel more ad hoc. So here's the second strategy. Perform algebra to this thing until you just see a perfect square staring. And the type of perfect square we'll try to see is just the fact that x plus b quantity squared is x squared plus 2bx plus b squared. And I don't know, that's quick, and it's the binomial formula, but how do people feel about foiling? Should we do that bit of foiling slowly? Any interest? Cool. Then, so if we can ever see x squared plus 2bx plus b squared in the thing we want to complete the square on, we can replace that with a perfect square and call ourselves good. Well, and then maybe do some more work, but we'll be mostly done. So let's explore that idea. So let's try to complete the square on the exact same thing. Let's start with y equals negative x squared plus 6x plus 3. And I'll use as my guiding template that I want to turn the side that has the x's into something that looks like that. And there's no set way to do that. There's some particular steps I've outlined in this case, but they're not magic. But on that side, the sign with the x's, I see a negative sign. I don't like that negative sign, because I don't see a negative sign in the thing I saw filled in yellow. So how can I get rid of that negative sign? Yeah.
Well, if the whole thing is equal to 0, you can just sort of move it all over to the left.
Oh, sure.
That's the thing that I thought.
Yeah, it's not equal to 0, it's equal to y instead. But let's
Oh,
use that
right.
same idea. Let's add all of that stuff to the other side, which would get rid of the negative sign in front of the x squared, and let's subtract the y to the other side. That's the same as multiplying both sides by -1, but let's do that. So you would add the x squared to the other side, subtract the 6x to the other side, add 3 to the other side, and then I want y to not be on that side. That's equal to -y. So now at least the side with the x's, I don't see a negative in front of the x squared. That's an improvement. So, if I look up there, I want to see an even number times x. I need to see 2 times b times x, or some b. So I need to see something times 2 multiplied by x. And then I need to see a b squared as the constant term. And I don't see that yet, and I think the 3 will just get in the way if I have it right now. I'm just going to move the 3 to the other side so I don't have to worry about it. Not an obligatory step. X squared minus 6x equals -y minus 3. Alright, so now I'm going to box in this Tom. That thing I would like to be 2 times b times x. So it seems like a good choice for b. So it sure looks like, so I see an x squared, which I like. I see minus 6x, I would like to see plus 2bx. So I need to have plus 2b equals negative 6. So it seems like a good choice for b.
-3.
Negative 3 seems like it'd do. So let's try b equals negative 3. But for that b to be negative 3, I need to see a b squared if I'm going to use that formula. So what should I add to both sides?
+9.
Plus 9. So let's add 9 to both sides just so I can see that showing up. Let's add a Tom, 9 to both sides. This will become x squared minus 6x plus 9 equals minus y minus 3 plus 9. Minus 3 plus 9 is plus 6, so make that substitution in a moment. And this thing is now a perfect square, because that is x squared plus 2 times negative 3 plus negative 3 squared. With an x, there's an x there. Oh, cool. That's a perfect square. I can replace it with a perfect square. It's x plus negative 3, so just x minus 3 squared. That feel okay? And that maybe feels more like what you were thinking as we're
Yeah.
completing the square is? Yeah. So if you like, this feels more ad hoc. So you have to like be more comfortable flying by the seat of your pants and just like trying stuff. The other one feels more algorithmic. I got 3 minutes. So that means I can replace that thing with x minus 3 squared, and that is now equal to minus y plus 6. But I don't want an equation like that. I want an equation that has y on its own. I want y equals. That easy to turn that back into a y equals equation? Yeah, just like add y to get it to the other side and subtract the square to get it to the other side. Or do something else. Y equals minus x minus 3 squared plus 6. Cool. And hopefully that agrees with what we had on the previous page. Nice. Does it agree with what we got on the previous page? Okay, that's good. So, with my 2 minutes left, I'm going to encourage you in the next 24 hours to use one of those 2 strategies here. What I'm going to close with is we have like a strategy for completing the square. I'm going to give you a thought strategy, and that thought strategy is a formula. I'm going to write down a formula. If you like internalizing formulas, great, internalize this formula. Here is a formula that completes the square. Whenever you see ax squared plus bx plus c, you can rewrite that as capital A, x plus capital B squared plus capital C, with big A equal to little a, big B equal to, gosh, little b over 2a, and big C equal to little c minus b squared over 4a. So, if you ever want to complete the square and don't want to do the walk, but you're comfortable looking up or just appealing to a black box formula, there's a black box formula. And you know what? To check that, let's apply it to negative x squared, minus x squared plus 6x minus 3. So it looks like I have a equal to negative 1, B equal to 6, C equal to 3. So yeah, looks like I get big A equal to little a equals -1. Does that agree with what's above? Awesome. Big B is equal to little b, so 6 over -2. That's -3. Oh, cool. That agrees with above. And big C is equal to little c, so -3, minus b squared, 9, over a, -1. So that's -3 plus 9. Yeah, 6. Okay, cool.
C is minus b squared over 4a is what you wrote there, so wouldn't that be -4?
Let's write it all out. So b is -3. So c itself was already negative. Little c is -3. Minus b squared is -3 squared. So I'll put the negative inside of these parentheses. All over 4a.
4 times -1 minus 4.
This is the trouble of giving lectures live. The other two coefficients are correct. Remind me to start on this. The formula that I've just given you for big C is incorrect. And in my -1 minutes, I cannot fix it. And like, the fix is going to be easy. It's going to be FOIL it out, see what it has to be. And so that's where I'll stop. Plus b over 2a the square. Got it, okay.
Can I help?
Yeah.
This is what I was talking about. Okay. I don't know why I'm struggling, but I am. And I think it is because like I'm like confused when it comes to like going in between these points or something like this. And then like no, I'm sorry. But I think I got like the one of these ones wrong. I don't know why. Like I think that's like it should be common sense, you know?
Is that the one you want to talk about first?
Yeah, I don't know, it's actually right there. I got both of them there, I got you. But like, these ones,
Okay, let's start with
I
range.
don't know why. Okay,
How do you check the range of a
I
function?
thought it was like when you down here and take the top.
Yeah, great. So what's the most negative y value you see?
Maybe that.
Negative 9. Is it included or excluded?
That's what I wasn't sure.
Is there an input that goes to -9?
Yeah.
Yeah, like 5 seems to do it. So it should be included. So, and is that y value actually -9? This is what sometimes written.
Yeah, it actually is.
Okay, good. What's the most positive y value you see?
Positive 9.
Is it included or excluded?
Included then.
And maybe let's check the intervaleliness. Does it actually achieve every output value in between them?
Yeah.
some of them twice, but
Okay.
being in the range doesn't care how many times.
Okay, I think I was thinking the range more of like, because I didn't know if this was open or not, so I thought like that I would stop like at this one, since that one was open, you know, but I.
Yeah, so that point isn't in the range twice, but it is in the range once.
Okay, yeah, that's true, okay. So we have that one, and then these ones, I guess when this one's increasing, I took it from, this point, cause I thought, or no, I don't know what one was, cause this one was increasing, I thought, and this one was like increasing.
So, yeah.
Yeah.
I agree. It looks like it is in, where's my blue chalk? Blue is the color that should be used sponge, please. I agree, it's increasing on those two. So what this problem is asking you is over what x values is it
Over
increasing?
X values.
Whenever you're asked for when is something increasing, it's
Negative
asking
nine?
negative 9 on 12.
Negative two? Right?
Yeah.
Okay, so I was not. Yeah, union, and then you have.
No, not union on
Oh,
because it's not increasing on the
Okay,
range, it's
okay.
increasing on each interval individually.
so these ones are off, like these intervals are off like the X values, not the Y's.
It's okay, I left one too.
So then it would be negative 9 to, wait, no. 6, no, 7. 7 to 9,
That's right.
and they're not included.
This one wants open intervals, and that's
Wait,
just,
it's positive 7.
oh, yeah,
that's
yeah, that's, it's positive, whatever it is.
Okay, so these ones are not including like brackets.
Nope, these are, it just wants open intervals.
Okay.
And this is one of the reasons that I wanted to harp on in class, like,
Yeah.
I want to include the endpoints, but I'm not
Yeah.
gonna harp on it, because some things will use different sorts of conventions.
Okay. Is this the same for like the decreasing and constant, except for the constant would probably, I thought that, so it'd be the X values, which is probably why I had the Y's. Okay, thank you.
Let's stop the recording.